I know I brought this up in class already, but I figured it was worth mentioning at least briefly here. There were some issues with the first lab as far as pictures of workbook pages being illegible and that sort of thing, and that's not really a fixable problem because since the solutions become available as soon as the deadline passes, there isn't a way to accept a good scan later. So to kind of work around that, this is how I wanted the submission possibilities to break down. Either entirely on paper or entirely on Canvas, but if it's going to be on Canvas, then don't use any pictures. Just type whatever you would normally write into the workbook and then take a picture of it. So the first option, if you're going to turn in the lab on paper, then presumably you'd use the actual workbook pages and just write in your answers and then pull those out using the perforations. Then along with the workbook pages, you would have printed pages with the stat key and R screenshots, and then maybe you'd have to write in the interpretation of the confidence interval and then the computation for the interval that goes along with the stat key screenshot on those sheets of paper. All of that stuff would then be stapled together and then with a cover page on top with your name and your section number and table number if you're in section 2. I guess if you're in section 8, obviously don't worry about that. There aren't tables in there. If you want to submit on Canvas instead of on paper, then just avoid using pictures of the workbook. The things you would normally take pictures of, just type those answers into a Word document, and that should work around that perfectly fine. Then along with that stuff, you would have screenshots of stat key and R. I guess that would also mean that you would have to use the equation editor for the question that involves the stat key critical value, but you wouldn't have to use the equation editor that much. So I don't think that would really be all that time consuming if you wanted to go that route. Then make sure that it's one document when you submit it on Canvas. I let that go last time and I told Sony and Dong Ying to also let that go, but this time that is going to be rigid where it's got to be one document. And the only acceptable file formats are going to be either a Word document or a PDF. So whatever you do, however you compile your lab together that you're going to submit, the easiest thing to do is just to say if you use anything else, then just save it as a PDF and submit that. That would be the simplest thing you could do. The first two questions in the lab both come from Beyond the Numbers 2.2 in the workbook. Exhibit 1, question 2 is at the bottom of page 131, and Exhibit 2, question 2 is at the bottom of page 132. Each of them would be worth 1 point, and you answer both of them the same way. Essentially what you do is you answer them the same way that you would answer the last two questions on class worksheet number 3, where you get your confidence interval and then at this confidence level, could we conclude that the parameter is above some specified value or below some specified value? That sort of thing, where you end up with answers like yes because the entire interval is higher, or yes because the entire interval is lower, or no because that number is contained in the interval. One of those types of answers would be what you would end up with. So there is a confidence interval that I think is lifted directly out of worksheet number 3. Is it reasonable to conclude the mean amount spent per day by all families of 4 vacationing in Niagara Falls is greater than 250? Well, if you look at the interval, the whole thing is above 250, so the answer that you would end up with would be something like that. Yes, the whole interval, the whole confidence interval is above 250. However, what about less than 275? Well, if you look at that interval, 275 is in it, or I guess the other way of looking at it is that part of the interval is above 275. So something like that. No, since part of the confidence interval is above 275, because the interval is supposed to give you a range of plausible values for the parameter, and with that interval, some of the plausible values are bigger than the 275, so that conclusion isn't going to work. With the two questions that are in the workbook that are similar to this, that are coming out of that Beyond the Numbers activity, it doesn't say, but just assume 95% confidence, and the intervals are easy to put together because the margin of error is already computed for you, so it's just point estimate plus or minus margin of error. And then you use those to make your argument, and the answers basically look like this. This or what's there in worksheet number 3. Beyond the numbers 2.15, which is on pages 171 and 172 in the workbook, the first question asks what the sample and statistic are. That's worth 1.5 points, 1 for the sample and 0.5 for the statistic, since that one's easy. It's just a number. Question 2 is asking for the population and the parameter. The population is worth 1 point and the parameter is worth 1.5. For the parameter, there are 3 things that you need, which are each worth half of a point. You need the type and number, so if the parameter is a proportion or a mean. You need the population, and you need the specification or context part. Question 3 is asking for a confidence interval, but the margin of error has already been computed, so it's pretty quick. Point estimate plus or minus margin of error, and that'll give you the confidence interval. Question 4, for that one, think about what would affect the margin of error directly. The only things that could possibly be the answer would be the confidence level and the sample size, and in this question the confidence level is fixed at 95%. So your answers should have something to do with sample size. If you go back to chapter 3, when we talked about the 4 polls about the popular vote and electoral college, the answer is basically sitting right there. It's that same argument there that's the relevant argument to make here for why the margins of error were different with those 4 different polls. Beyond the numbers 2.26, which is on the workbook on page 201, question 1 is effectively a 2-word answer where the second word is variability and the first word starts with an S. That one's not too bad, which is why it's only worth half of a point. Question 2, the best way I can put it is that it's what you think it is. You can make that one precise if you want to, or you can just use the colloquial idea. That's fine. Don't overthink this one. It's what you would expect. Question 3, there you want a specific type of non-sampling error. And this one goes back a little bit. This stuff is actually in chapter 1. The non-sampling errors, to be more specific, are toward the end of section 1.2. The answer that you want, the exact phrase that you want, is in there. It's in the back half of section 1.2 if you just go and look through those notes. So that's what I would do there. Number 10, the first non-workbook problem in this lab. It's the longer interpretation of a confidence interval that we went over in class along with the section 3.2 notes. You've got the confidence interval there in that initial paragraph. We have the 95% confidence interval, and then you want to give the long interpretation. If you want to use mine as a template, that's fine. I think that will absolutely work. That will give you a correct interpretation, and that would be the simplest way to get there. It's on the 5th page of the section 3.2 notes. It's in between the asterisk border where it says better interpretation. That's what you want to use here. To be more specific, it's this. It's that thing that's in quotes toward the top of the screen right now. If you take that, substitute in the correct confidence level in the 2 appropriate spots, and get the right parameter in there, that will work. This is worth 2.5 points. I think 1.5 will probably end up being the parameter, and then the other 1 point will basically just be the rest of it. The other thing I need to mention about this question is if you do the other kind of interpretation, I can't give you any credit there. The entire point of this question is to use that better, longer, more thorough interpretation. So if you have an interpretation of the we are 95% confident that parameter is inside interval variety, that's entirely missing the point of the question, so there won't be any partial credit. Number 11 involves getting a confidence interval for a mean, but while using stat key in order to get the critical value from the t-distribution. This is the one where different people are going to have different sample values. If you're in section 2, which is the 5 o'clock class, that has tables, so your table number is what determines the set of sample values that you're supposed to use. If you don't have a specified table on Canvas, then you need to come talk to me about it if you want to be able to receive credit for this problem. If you don't have a table number by the time that you submit this lab, then there's no way you can get credit here. So that note toward the bottom, if you don't have a table number, all 4 of them are incorrect sample data. Section 8, there aren't any tables, so I had to do it based on alphabetical order. But as far as what you want to have for the critical value screenshot, you want it to look like that. That's the bare minimum of what you would need from StatKey. You need the curve with the 0.95 in the center where you can clearly see what the critical value is on the bottom, like how mine is 1.980, and you need the degrees of freedom over on the right. You need that box to be included. It does say that on the page for the lab. Make sure you don't crop out the degrees of freedom box, and that really does have to be in there. After that, then it's basically just substituting it and then doing the algebra. If you're typing it, that's going to involve Microsoft Equation, but it's not going to be too bad. The last three questions involve using R in order to compute confidence intervals, and you can use my scripts that I wrote from when we went over this in class to do them, and that's going to be the simplest way to do it. The first two of those are worth 3 points each, and the last one is worth 4. The last one uses a preloaded data set, and there are a couple of extra computations, so I figured that was worth a little bit extra point-wise. For number 12 and number 13, you just have to add the sample data into the appropriate script, and you'll need each script once, since one of those is for a mean and one of them is for a proportion. Then copy the script over into the console, and then you'll have to retype endpoints and print that to get the two endpoints, but that's about it. As far as what I would want for a screenshot, this is what the screenshot should look like. You need all of your R code in there, which mine is all going to be in red because I did this in Windows, and then my output, the interval endpoints, are in blue. If you have a Mac, the colors will be different. I think you'll have blue input and black output instead of red and blue. That's fine. There's nothing wrong with that. For whatever reason, for different operating systems, those colors change around a little bit. But this is the exact thing that you would need, just with different numbers. Obviously, the numbers that are there don't match the numbers that are in the lab, but it's this idea. Number 14 is like number 4 on the worksheet that we did that covered the R stuff, where you have to use one of the data sets that already exist in R. In this case, you want the Lake Huron data set, which if you take a look at it, so data of Lake Huron, now it's in there, and if I just print out Lake Huron, it's a single variable. So it's not like the Warp Breaks data set that had multiple columns where then you had to pull a column out that you needed. Once you have the Lake Huron data recalled, then mean of Lake Huron and SD of Lake Huron will work. So what I would do in order to get the confidence interval there, since this is for a mean, you're going to be using this script down here. I would just put mean of Lake Huron right here and SD of Lake Huron right there. The other thing that you would need is the sample size. That's actually in the wording of the lab. You could get it by counting, but you don't have to. It's there in the lab, so just use that. And then from there, it's just copying the script over. So that's what I would do. The one other thing I should say is just be careful about case sensitivity, because whatever you put into R is going to be case sensitive. So L in Lake and H in Huron do need to be capitalized.